Hello guys, it's time to look at worked examples on projectile. In our previous lesson, we derived formulas on projectile that could help us solve virtually any kind of question on projectile. So today we're going to be starting with this very first question on the board. So, a body projected upward from the level ground at an angle of 50 degrees with the horizontal has an initial speed of 40 meters per second. How long will it take before striking the ground? Now don't forget the formulas we derived in our previous lesson. We derived all the formulas. We derived formulas for the total time of flight. We have time of flight along mass height, total time of flight, mass height also. We have range. We also derive formula for landing velocity and also formula for trajectory, that is the parabolic path a given parabola passes through. So quickly, let's see if you can quickly write out some of the formulas. Total time of flight. Don't forget what we derived. We got that from V, got to U plus AT. So that is 2u sine, that's u sine theta minus gt. So 2u sine theta divided by gravity. The time of flight for mass height is u sine theta over g, but total time of flight is 2u sine theta over g. Don't forget this. And also we got the formula for mass height, h max. Mass height is, don't forget we got that from v squared equal to u squared plus 2ax. So that's u square sine square theta over 2 gravity. So we got this. Also for range, we got the formula for range, which is distance along the x-axis. We got u squared sine 2 theta over gravity. And we got more formula. We got the formula for landing velocity, and the very last one, which is the trajectory. So we're going to be, don't forget this formula. All those formulas are right. If you have not seen the previous lesson, please go ahead and see that very lesson in order for you to understand what we're about to take. So all those formulas will be needed for us to solve this. So let's say a body is projected upward with upward from the level ground, at an angle of 50 degrees. That's a theta. Theta is 50 degrees with the horizontal. As an initial speed. Initial speed is 40 meters per second. How long will it take it before striking the ground? Now, we have been asked to get how long it takes the body. Now, look at this. This is a picture, this is an image that will help us understand. So the body goes like this from the level ground. It goes up and falls back. So what happens? There's a mass height attained here. That's a phase one, as said in the previous class. The body being shot from the level ground, get to the mass height before falling back to the ground, to the same level ground. So it was shot with this 50 degrees with an initial speed of 40 meters per second. So we can use the formula method, or we could use the what are calling it, analytical method. But let's use the formula method to save our time. You understand? So what do we do? What do they want us to get? The time it takes before striking the ground. Now it's going to take. You have two types of time. You have the time it takes to get the maximum height, and the time it takes to fall back. So what I want us to get is the total time of flight, which is 2u sine theta over g. Don't forget that we got it from this. V equal to u plus at. At max height, final velocity is 0. Initial velocity is u sine theta. We know what that is already. Gravity is minus gravity. So that is 0 equal to u sine theta minus gt. We send the gt to the other side. So for time at max height is u sine theta over g. So for total time of flight is 2u sine theta over g. So let's use that. The total time of flight, 2u sine theta over gravity. This is the formula we're going to use. So how do we get the total time of flight? The 2 times initial speed is 40 times sine, what's the sine of the angle? Sine 50 degrees divided by gravity, which is 10 meters per second squared. Let's take it as 10 meters per second squared. So we're going to be using our calculator to solve this. We're going to be doing that quickly. 2 times 40 times sine 50 divided by 10. We're going to do that. 2 times 40 times sine 50 divided by 10. We have 6.128. 6.128. That will give us 6.13 seconds. So that's the total time of flight. The time to get the max height is just divided by 2, which is 3.06 seconds. So this is just the way to solve it. So I want to expect more examples. My examples are on the way.